Hey learners, welcome to Connected. In today's class, let's dive into the chapter of the applications of trigonometry. So without any further ado, let's get started. Students, you learned about trigonometric ratios in the previous chapter. In this chapter, you will learn about some of the applications of trigonometry in everyday life. Trigonometry is an ancient topic that is still studied by scholars all over the world. As we saw in chapter 8, the need for trigonometry emerged in the field of astronomy. Astronomers have used it to measure distances between the Earth and the planets and stars since then. In addition to mathematics, trigonometry is used in geography and navigation. Trigonometry is used to create maps and to calculate the location of an island in relation to longitudes and latitudes. We will explore how trigonometry may be used to find the heights and distances of various things without having to measure them in this chapter. Let's study about heights and distance. First, let us consider the first figure of the previous chapter, which is redrawn in the figure shown. The line of sight is the line traced from the student's eye to the top of the minar in this diagram. The student is gazing up at the minar spire. The angle of elevation of the top of the minar from the student's eye is defined by the angle BAC created by the line of sight with the horizontal. As a result, the line of sight is a line drawn from an observer's eye to a point in the thing being observed. When the point being viewed is above the horizontal level, that is, when we elevate our head to look at the object, the angle created by the line of sight with the horizontal is called the angle of elevation of the point viewed. Consider the condition depicted in the previous chapter's figure. The girl on the balcony is staring down at a flower pot on the temple stairwell. The line of sight is below the horizontal level in this situation. The angle of depression is the angle created by the line of sight with the horizontal. The angle created by the line of sight with the horizontal when the point is below the horizontal level, that is, when we lower our head to look at the point being viewed, is therefore the angle of depression of a point on the object being viewed. You should now be able to recognize the lines of sight and angles created in the diagram. Are they inclination angles or declination angles? Let's take a look at this diagram. What information is required to determine the minar's height CD without having to measure it? You will need to know the following details. First, the distance DE between the student and the minar's foot. Second, the angle of elevation BAC of the minar's top. And the third, the student's height AE. How can we determine the height of the minar if the above three conditions are known? In the figure, CD is equal to CB plus BD. Here, BD is equal to AE, which is the height of the student. To find BC, we will use trigonometric ratios of angle BAC or angle A. In triangle ABC, the side BC is the polar opposite of the well-known angle A. Which of the trigonometric ratios are we going to use now? Which one has the two values we have and the one we need to figure out? Since these ratios include AB and BC, our search narrows down to either tan A or cot A. Therefore, tan A is equal to BC by AB or cot A is equal to AB by BC, which on solving would give us BC. By adding AE to BC, we will be able to find the height of the minar. So, to understand things better, we are going to look into some examples. Let's look into this first example. You can see this tower which stands vertically on the ground. From the bottom of the tower, we are going to a point which is 15 meters away. We are provided with the information that the elevation angle of the tower top is 60 degrees. We have to find out the height of this tower using the provided data. To simplify the situation, let us draw a simple diagram which represents our problem. In the diagram, the tower is represented by AB. The distance from the bottom of the tower to the point is presented as CB. And finally, angle ACB is the elevation angle. Here we can see that ACB is a right angle, B being the right angle. So, in order to find the height of the tower, we need to find the value of AB. As we know the value of BC, we can apply the formula of tan 60 degree cot 60 degree as it involves the ratio between AB and BC. So, now we get tan 60 degree is equal to AB by BC. That is, root 3 is equal to AB by 15. That is, AB is equal to 15 root 3. So we can say that the height of the tower is 15 root 3. Now we are going to take a look at another example. Here in the picture you can see an electrician is trying to repair something on an electrical pole which is 5 meter tall. The electrician has to work on a point which is 1.3 meter below the top point of the pole. If the electrician uses a ladder at a 60 degree angle against the pole, what should be the height of the ladder so that she can reach the required point? Also, we need to find out that from the base of the pole, what would be the distance from where she is going to put the ladder. To ease up the calculation, we can take root 3 is equal to 1.73. As you can see, the electrician has to reach the point B in the pole which is marked as AD. So, the height where the electrician has to reach is BD is equal to AD minus AB, that is equal to 5 minus 1.3 meter is equal to 3.7 meter. The ladder is represented by BC. Here we can get a right angle BDC. Here, to find the length of the ladder, we need to find the value of BC. Here we are going to use the trigonometric equation sin 60 degree. So we can say BD by BC is equal to sin 60 degree, or 3.7 by BC is equal to root 3 by 2. Therefore, BC is equal to 3.7 into 2 divided by root 3, that is equal to 4.28. So we can say that the length of the ladder is 4.28 meter. Now we are going to another equation to find the distance between the pole and ladder. DC by BD is equal to cot 60 degree, that is equal to 1 by root 3. So we can say that DC is equal to 3.7 divided by root 3, and that is equal to 2.14 meter approximately. So the distance from the ladder to the foot of the pole is 2.14 meter. Let's look into another example. Here in the picture we can see a 1.5 meter tall observer in front of a chimney which is 28.5 meters away from her. The elevation angle of the chimney top from her eyes is 45 degree. We have to find out the height of the chimney. From the diagram we can deduce some information such as the height of the chimney is AB and the height of the observer is CD. We can see that the angle of elevation is angle ADE. So in this case, ADE is a right angle triangle. The triangle is right angle at point E, and we have to calculate the height of AB. So we can say AB is equal to AE plus BE is equal to AE plus 1.5, and also DE is equal to CB is equal to 28.5 meter. As we need to find the value of AE and we already have the value of DE, so here a trigonometric equation has been chosen where both AE and DE are involved. So tan 45 degree is equal to AE divided by DE, that is 1 is equal to AE by 28.5. Therefore AE is equal to 28.5. So the height of the chimney will be AB, which is AE plus BE, or 28.5 plus 1.5, that is equal to 30 meters. Students, now let's do a fun exercise. Try answering them. First question, give one use of trigonometry in the real world. Second question, what is an angle of depression? Now let me discuss all the answers. First one, trigonometry is used in geography and in navigation. Second, as seen in figure 9.3, the angle so formed by the line of sight with the horizontal is called the angle of depression. With this, we have come to an end of this class. I hope you all enjoyed the session. See you all in the next class. Thank you.